Pandas data frame functions actually allow us to do all kinds of things, from importing to exporting data, creating test objects, viewing, inspecting data, cleaning, filtering and sorting, grouping by, join, combine, and all kinds of stats. Okay. Now I actually got all of these slides that you're gonna see. I think next couple of slides, 8 slides, I guess. I got it all from DataQuest website. So there's an excellent blog about data frame functions, and most of the things that you're gonna see are from that source. Okay. Now the first group of functions are importing data, and so far we've been using CSV import, but you can actually also import from all kinds of other files, like Excel file, from JSON files and SQL tables and so that. Okay, all of that is possible as well. Right. So for our examples, we're just going to go ahead and use the CSV, and we already did this, right? So we actually took a dictionary and actually converted this. Okay. So the PD here stands for pandas. So make sure that you always use that when you import. I cannot stress this more than enough. Exporting, we're going to use this to export the clean data. I won't use that too much, but I'll show you why that could be useful. And you can also export in multiple different formats. It's so easy to use. You can create test objects using NumPy random function. So this is, remember, this is NumPy. Okay. So this basically says there's a random function that gives you random numbers, basically 5 columns and 200 rows of random floats. Okay, so here the structure is rows and columns. Right. All right, so you can actually create a series from a list. Series is actually a data frame structure. It basically takes one column. Okay, you can think of it as one column, and it's a series data structure. And then you can create an index from a date range. So this is another function, date range function. You can actually take it and create a date structure. Okay. You can use functions in Pandas data frame to inspect data. So we are going to use, for instance, you can look at the head that we do. You can actually look at tail. You can say, okay, give me n rows from the top or the bottom of the data frame. Okay. You can describe that we have done this. You can look at value counts. We're going to do that as well. Okay. Right. And we also apply. We can apply certain kind of function to a given column. That's also there's so basically apply allows you to apply a function. Okay, here I'm applying a series that value counts function to all my data frame. Okay, and that gives me unique values and counts for not only one column but all the columns. Okay, that apply allows you to, and you can, we'll later on see there will be all kinds of different functions in apply as well. All right, selection. In terms of selection, we have shown already, we can select columns. We can select multiple columns as well. So all you have to do is make sure that you have these 2 square brackets and you have the column list. Okay, so from your data frame, you can pick any set of columns. And we have already used this. You can actually use it with an index by position, iLock, or you can with you can get the first row, and you can get the first element of first row as well. So you can actually access each element using these iLock and lock functions. Okay. So this is for selecting subset of your data, whether a column or row. You can also clean your data. You can rename columns, check to see whether the values are null or not. You can drop all rows that contains null values, so using this. So all kinds of functions that allow you to clean up. Some of the functions here is you can actually replace all null values with an X. So this is basically a missing values case. You can actually replace missing values, right? So there are a couple of alternatives here in terms of what you're going to do with null values. So there are 4 different ways of treating null values. Okay, so of course this can be mean, this can be many things. X can be anything, any set value. It could be, or it could be a mean calculated based on data. Now, like this. So here I can actually take the series. So here S stands for, let me write it. So S is series, right? So this is a series object. You take the series object and then you fill it by the mean of that series. Okay? So all kinds of other functions you can replace, rename, set indexes, and so on, right? So you can rename the index as well. Some of these functions I'm going to use, so that's why I'm showing you this. We can filter, sort, and group by. So we can actually, select a certain set of rows where the condition is met. So here you have a condition, and based on that condition, you only get those columns. Okay. You can have multiple conditions, so you can have two conditions on the same column. Right? You can sort values based on a column. You can sort values whether it's ascending or descending. Okay? And then you can sort values based on two columns, multiple columns as well. Okay? So you can actually change the ascending and descending of both of those columns. Relatively easy functions to use. Group by is very powerful. I'm sure some of you have used SQL group by, and some of you have used pivot tables in Excel. That's exactly what this does. Okay, so your group by allows you to take a column or multiple set of columns and group your results based on those columns and do some aggregate function. It could be a sum, it could be count, it could be mean, all kinds of functions that can be done. Okay, so the simple format, and so you can group by single column, multiple column, or you can group by one column and then pick another column. So here what you're doing is actually you're grouping by one column, column 1, and then you get the column 2 values, and then you can go ahead and calculate the means for it. There is also pivoting. So you can actually take a column and pivot it. So here what I'm doing is actually I'm taking an index column, and the values are column 2 and 3, and an aggregation function is mean. So what I'm doing is actually I'm taking the mean values of column 2 and 3, and I'm pivoting on those two on column 1. Okay, so whatever the column 1 values are, I'm pivoting on that. I'm showing you an example of that with the COVID data set. Okay, all right. Right, so there's another option here. I'm finding by grouping, I'm finding the aggregation, and then here I'm using numpy's mean function to get the mean. Right? So here I'm taking the mean function and applying across each column, and I'm taking now apply an npmax function and across each row. So there's different ways of doing this. So you can also use joins and merge. You can actually append data frames to each other, concatenate, join based on columns, and how you decide. You can do left inner joins or outer joins as well. So all of those are possible as well. Okay. Now, the next set of functions are statistic functions. We have seen some of them, like describe gives you all kinds of details, but there's also mean, correlation, count, max, mean, median, and standard deviation. All those can be calculated based on the entire data frame, or you can calculate them based on a certain column. You can do a column selection, so you can just say df, and then make a selection of single column, doesn't have to be text, and then you can do these functions. You can just say mean. Right, or any other function. Right, and this selection could be column 1, column 2. So let's make them string. So that can be done, and dot you can do mean as well. Okay, that's possible as well. So in this case, right. All right, so to use all these functionality that I've shown you, I'm going to use two data sets. One is the nations data set. Okay, so let's look at this data set. And those of you who are in my classes, you are using this, especially in the visualization class, we are using this quite a bit. Okay, in the Python class, you may be seeing this for the first time. Okay. All right, so the nation data set is basically a simple data set that has, for various countries, it has GDP per capita, and then life expectancy, and population, and birth rate, and neonatal mortal rate, and region, and income. Okay, so these are the columns that we have. So we're going to import this and do some graphics on this data set. Now the next data set I'm going to use is the COVID data set. All right, in the COVID data set, what we have is we have 597 rows, and then here is the bottom, here is the top of those rows. So for each country or region, so you notice it says country or region, because sometimes it's going to be a region like US, it will be in like states, or it could be just the country itself as well. For each country and region, what you have is you have two rows. For instance, for Bahamas, you have row 3 has like for that day, like February 27, number of deaths were 0 in Bahamas. There is also another row for that country, it's called confirmed. Somewhere in this data set, there is another row confirmed with case number and difference, and there is date, that will be the exact same date, 2020, okay, and it will be Bahamas as well. Right? So the rows represent, one row represents that, other row represents number of confirmed cases. But this is not what I want. What I want is a table where I can actually have for each country, I can have a column with confirmed, and I can have death. Okay? So now I can actually take this and divide, and I can find the death rate in that country. Okay? So to do that, I need to pivot it so that I get this. I'm going to clean some of the rows as columns as well. I'm going to have basically for each country, this is the index, right? I want to have a date, and for that date, I want to have confirmed in one column, deaths in another column. Okay, so pivot this so that I can have this. Now, for those of you who are in the visualization class, I'm doing this in relatively easily in Tableau, but you can also do it in many other tools, including Python. So, all right, so let's look at some examples, and we're going to use those two data sets, large data sets, to do some analysis. All right, the first one is the load. So here is, I'm going to load two files. One is the nation CSV, another one is COVID. Then I'm going to do row selection. So in nations dataset, I'm going to actually pick only year 2014, and in COVID's dataset, I'm going to actually pick only 6 countries. So I'm going to focus on 6 countries, not entries. Okay. So those are the row selections. So I'm doing them. Both of them are done using a log function. Okay. So in this dataset, this is the COVID dataset. Okay. V is the COVID dataset. Okay. This is the data frame for COVID dataset. Right, so right here, I'm reading, this is a data frame. Okay, now this is a, V is a data frame. Okay, all right, I'm going to pick columns. So in one case, I'm going to pick actually life expectancy, right? And in another case, in the V, I'm going to pick date, country, region, and confirmed. Okay, all right, I can here pick a subset of data as well. I can peek into the data frame using the head function, and I'm going to use that. You'll see that into, and then I can actually look at the columns. And to look at the columns, just peek into the columns. Okay, I cannot even write. Okay, here we go. To peek into columns, I can actually use data frame.columns and turn them into a list. I'm in the font. You're going to see it shortly. What else? I can pivot my data frame. So what I'll do is I'm going to pivot the COVID data set. So I'm going to pivot, and index will be 3 columns. So I'm going to date, country, and region. So I want to get case type as a new column, right? So this is the column. So I'm going to have case type as the new column, and then the values will be cases. So that's what I'm doing. So I'm basically saying, go to this data set. Look at all the confirmed cases for a given date, country, and region. Okay. And what was the third attribute? So let me see. What attribute did I have there? Oh, 2 attributes. Okay. Sorry, I said 3 attributes, but country, region, and date. Okay, that's why I got confused. Okay. So I want to take date and country region and pivot the case type column, so that I'll have 2 new columns, one for confirmed, one for dates. Of course, if I had more, I could have done that too. It doesn't matter. So however many case types I have, I'll have 1 column for each. That's what the pivot does. All right, so that's what the pivoting does. So here you go. So here's the index column. How do I group? And what are the case type? And then what is the function? The function here I'm using an aggregate function is MP sum. I'm using NumPy sum function because I'm going to sum each of these values, because if I have a country with multiple states like US, I want to sum their dead figures. Okay. I'm using sum because these are cumulative values from day to day, so I don't want to do cumulative sum, I want to do the sum. Okay. Then I'm going to do aggregation. So what I'll do is I'll do an aggregation for a given date. So I'm going to create a new data frame. In this new data frame, basically I find daily dates. Okay. So here I just do a sum of dates, right, for a given day, right. And once I can pivot, then I can do this. I can create a new column, and the new column is basically take the dates and divide by confirmed. Now, if you cannot do this without, well, you can, but it will be very hard to do. You have to write a lot of Python code to do it. But once you do the pivoting, this becomes relatively easy. That's all, and that's the formula. Very simple. Okay. Here's a new column you create by taking 2 columns and dividing them. Now, we will also use datetime package. It's a separate package. It allows you to create dates and then also do what we call date arithmetic. You can do some date calculations. Okay. So you can take a value and turn it into a datetime object. Once you have the datetime object, you can actually go find the start date. Again, I'm going to show you how we can find the start date. It's right here actually. Here's the start date. Okay. So where do I start my analysis? How do I look at my code data and how far do I go back? So I go back 45 days, and I'm going to get to that. But for what I do is basically say, okay, get me the start date, find me the start date, and basically select all rows after start date. Okay, so I remove everything else before. So I do a row selection using my log function. I say vdate is greater than start date. How do I then find the dates? I can actually use functions that are available in datetime package. Like for instance, I can use the today function to get me the today's date. And today's date will be a datetime value. We'll have a date and then the time itself, the current time at that point in time. But I want to remove the time. So that function does that too. So I basically remove time. So what I have left is basically I have year, not necessarily in this format, month, and day. Okay, so I get that format by using date function. Okay, and then I can find tomorrow by using a time delta function available in DT. DT stands for, this is the alias for datetime package. Right? When you import your packages, make sure that you use these standard aliases. Otherwise, it will be hard for other people to understand what you're doing. Okay? For datetime package, it's always DT. And the start date is basically I take today and take delta days. It's basically 45 days and a subtract. So it basically goes back, finds the date 45 days before today. So that will be my window. So I'm going to start from start day and I'll go all the way to tomorrow. Right, so when I do my graphs, I want to plot all the way from the start day until tomorrow, so it's easier to see. Not today, but tomorrow. Or I can do 5 days later, so that it's, if I'm doing especially forecasting, I can change that tomorrow to some future date as well. Okay, so this is the date arithmetic. All right, and then we're going to do some visualizations. So we can do some simple visualizations using the plot extension that's available in Panda. So it's an extension available in Panda. So I can do a simple plot, like take the daily deaths and just take basically this is going to be a line plot by default. So a simple plot is line plot, and X is date and Y is total deaths. I can do a complex version of that, like the very complex version here. Actually, I'm going to explain that shortly. Okay, so I'm basically taking the death rate for different countries and plotting a line for each of the countries. I have 6 countries selected. I'm going to print a line for each of them, and I'm going to go ahead and color them. So color them by each country. So here, this version says, okay, get the country and then give it a different color. And this is the order, and this is how the colors will be ordered from top to low. Okay, and then I assign a palette. I create a palette and assign. I can change the color palette as well. Okay, I can change the size. This is the size of the line, and then I can add additional functionality to plot. These are all adding functionality to my plot. Okay, step by step. This is called method chaining. You basically add method after other method, and this is, so this thing is one single line. So from here to this is a single line, and this is what? Multi-line continuation character. Right? So it allows you to write a single whole line into multiple lines. Okay? So this whole thing is one single line of function. So you're chaining one function another. So here you're deciding what the plot type is. So it's a pie plots plot line plot, and you specify what is the limits for X and how many ticks are there and what labels you're going to put. You can decide all that, and rotation of that labels and how it's aligned on all that. Okay, so here I'm using a range function to decide ticks are starting from today until tomorrow, or start day from the tomorrow, and then this is the range. How many ticks are there? This is going to decide. Okay. So this is how the ticks are placed. So it's kind of a complex way of doing this. Right, so this is called the facet grid of Seaborn, another package that we're going to use. So SNS stands for here, right here. SNS stands for Seaborn. All right, so let's go ahead and do some of these examples. So let's get to it. Now, I have a bunch of files for these in my folder. So let's find them. Right here. So I basically have 2 database examples, and these will have the library examples, figures examples. But I'm going to start with the COVID. So I'll start with the COVID and look at a few things in COVID, and then come back to nations dataset. And then nations datasets are accessed by these 2 libraries, so these 2 files. Okay, so let's start with COVID. So I'm going to open up NN. NN is basically my Python code for accessing and modifying my COVID dataset. So first, I basically go ahead and I do also have instructions here as to how you can install these packages in Wing. So go click on this link if you are running these. And then I'm importing a bunch of libraries. I'm importing pandas, I'm importing NumPy, matplotlib, and I also datetime. Okay, again, all these are standard. And then again, I have written all kinds of comments here to explain what is going on here, what I'm doing. But nonetheless, I will just go ahead and run them as well. So, All right, here we go. We set the style for Seaborn, how the Seaborn library should be. So it's another library we import as SNS. And then we assign get the dates, okay, and then print these dates and see if they're correct. And then I go ahead and read the COVID data set using Pandas data frame read. Once I get this, I have a data frame called V. Now V has all the data I have. So let's go ahead and run this quickly. It takes a bit to run. While it runs, let me talk about it a little bit more. And then I look at the head, and then I look at the columns. So here, this is the cases. So here are the dates. This is the start date. I'm starting from March 3rd. And I go all the way till tomorrow. This is the 17th. Okay, so today is 17th, and tomorrow is 18th. Okay, so I go all the way there. And then the top is, this is basically, you notice this is the unpivoted data set. Okay, so basically I have 5 rows and 13 columns, at least in the head. So it's still going on. So let's go let it run. Right, so once I run it, the next thing I want to do is, so let me get rid of these figures, let's print these plots. But before I get to the plots, what do? I basically print this. So this is basically my columns. So this line, I'm actually printing, first I'm printing the head, and then I get the columns. So this is all the columns I have. So let's look at this quickly. So I have case type, cases, difference, all the way. So I'm getting a list of all my columns. And then I go ahead and basically change the dates, take the date values from my table and make them into a datetime object. Okay. So here I can do alternative formats. I can change the formats as well. I'm not doing it, but just leave it like this. And then I go ahead and only select rows that are after the start date. And then I go ahead and pivot. So once I pivot, after the pivot, I think let me go ahead and print this. Okay. I did not print this, but let's do this. Okay. All right, so let's go ahead and print this. So right after this, I want a pivoted version. All right, it will take a while. So let it run. Once I do the pivoting, I do create a new data set, which is basically I group by date, just like we did in the baby data set example. And now I basically take the dates and find the sum. Now I do sum, I don't do a cumulative sum because here the dates are already cumulative for each region. So because of that, I don't need to do the cumulative sum. I'm just doing sum. Okay, that gives me the daily sum for each of the days. Okay, and then I basically say, all right, so that's what happened. Oh, yeah, I did a typo. So this right here. I should say head, not heads. Okay, let's go ahead and run this. Okay. So once I do that, I basically get the aggregate sum for each day. Now I then go ahead and print this daily. Daily now has index, date, and total dates. Okay, so it's the different data frame. It's not the same frame. I don't need to combine this into my frame just like I did in the baby data set. But if I did, I could have actually went ahead and combined this as well. I don't need that number. I don't need the total dates number in there. Okay, because it's as it is already cumulative. Okay. Now after that, what I do is I basically do a calculation. I take two columns and divide one to the other and come up with this that rate. Okay, so let's look at now. All right, so let's look at now the pivoted. So now here is the original data set, and here is the pivoted version. Now I have date, country, region. I have confirmed, and that's as two new columns. At some point, I'm writing this new version of the table to an external file because it makes my runs next time. If I keep running this same file, I could actually just use this file. I can just focus on only this data frame. I don't have to reload the whole thing. Okay, I can just focus on this. Okay. It won't save a lot of time. It still has a lot of rows, but nonetheless, it may save some time. All right. Then I basically go ahead. I find the confirmed, and I lock. I basically select only these specific countries, and then I go look at the unique. This basically gives me all the unique countries I have, just to make sure that I have the correct countries in it. So this is where it does. So right here, I'm printing all 6 countries right there, just to make sure that I did not make any errors in these conditions. Okay, here I have conditions, and this basically is called exclusive OR, so a bitwise OR. So what this does is basically, if any of these conditions, suppose there's a null, evaluates to, it doesn't evaluate, it still works. If you do write OR, in that case, if one of these conditions fails, it's not going to work. Okay, so this is to basically use this OR, bitwise OR, so that we can actually make sure that null values are not impacting our result. Okay. Alright, so when we do that, and then we write it. Right here, I'm actually writing this. I'm writing it a new file. Let's look at that file. I think I did write it now. So right here, this wasn't there, and you see it's written. Okay, open this up quickly. Right here. So it has date, country, region, confirmed deaths, and death rate. You see, there is a death rate. There's a percentage of people who are confirmed are dying. Okay, for each country and all 6 countries, and this doesn't have many rows, 8,000 rows. All right. Now the next thing I would do is I'm going to go ahead and plot this. I'm going to create a plot using pandas plot extension. Very simple plot. I have date and y. This is a very simple XY line plot. Okay, so let's look at that plot. So it's this plot. Okay, so this is the total deaths, about 140,000, close to 140,000 now, and this, you can see the exponential increase. Okay, that's that plot. Okay, so let's close that plot. The other 2 plots are open as well. All right, so here we can change the scale. We can set the scale to Y scale or X scale to a log as well, but in this case we don't need log, so I'm gonna not use this option. And then the next thing I'm doing is I'm actually saving this now. I'm actually saving it into a file. Let's look at it now. So I should have, in that same folder that I was using, I should have figure 1, figure 2, and figure 3 right there. So these are saved as well, so I can actually look at them later. Right? And then I go ahead and create labels. So I basically create labels, and what I'm doing is kind of complex here. So I'm explaining it one at a time, but here is what I'm doing. I'm basically taking the date field from my data frame, and I'm using date time package, and I'm using actually string time. So I'm actually taking the time and creating a string from it, and that string is basically month and day, because I want, on my figure, I just want the month and day. I don't need the year because all my dates are in 2020. So because of that, I just want this format. So if you look at my now figures, if you remove this, I want you to go ahead and try this, remove those, and see what it will look like. So that way, you see my figure now, I have 3 and I have 412, okay, for the years. Okay, so for each country, I have how the death rate changed over the years. You notice Turkey is kind of flat. That was the main issue that drove me to this data set. And you look at various countries. Here is Spain, here is France, Germany, and Italy. I'm going to explain, this is called facet grid. I'm going to explain that shortly. All right. So then I print labels to make sure that these labels are what I intended. So here are the labels. So here are the labels for the original data set, and here are the labels for the updated data set. So I have 2 different labels. Okay. All right. So this is the first figure, this is figure 2. So let's look at figure 2. So these are labels for figure 2, these are labels for figure 3. So let's look at figure 2. I'm going to go to my folder and look at, just to make sure. So figure 2 labels, you see that it has more labels. Okay. Because I have more room, I put more labels there. Figure 3 is the final figure, is this facet grid. It's called small multiples. I'm looking at each country in a different box. Okay. For that plot, I'm using less number of days. Otherwise, it becomes very crowded here. To change that, basically, I'm creating labels. So these labels are here, created so that I can have only a certain portion. How do I reduce the number of values? I basically take all the values in that range. I basically slice it. So this is slice. Remember from slice? So I'm saying start from all the way at the beginning, go all the way till the end, and get every other value in the label. And then I go ahead again, when I do the label for those small charts, I get every 5. I basically get 1 out of 5 the labels. So that's how I basically reduce the numbers. You can change this number, you can pick anything, you can look at how it responds. All right. Now for this figure 2, sorry, I create different kinds of color palette. So you can actually, I have a link for this. You can actually go look at how you create these palettes. These are basically colors. These are all RGB codes for these different colors, basically. Okay. I think they're RGB codes. I'm not 100% sure. And then I create the palette. Palette is basically created. You notice I'm using a zip function. I'm using a dictionary. So it's basically the palette is a dictionary. Okay. So I'm basically saying, okay, take my data frame for each country region, find the unique countries, and then from the color palette, use these colors for each country. I'm assigning one at a time. So I'm zipping them, and then I make a dictionary out of this. For each country, I have a specific color for each country, and those are those colors. So they are given in this list. Okay. All right. And then I go ahead and plot. The first plot is that plot, this figure 2. And you notice here is the formula for that plot. So the formula is somewhat complicated. So the code is complicated. So I'm using something called a facet grid. The facet grid allows you to create what is called small multiples. But if you choose, you can actually create only, if you don't specify, okay, a column, you can actually have multiple plots in the same picture. Okay, so what I'm having is, I basically, all these lines, each line is for one country. Instead of plotting them into a single plot, one at a time, I'm plotting them all in the single plot. Okay, I'm using that facet grid to do that. In the alternative option, I have another option. I'm basically creating now the column, means take the country and then create a small box for each country. This column attribute of this facet grid, that means that, okay, what it will be the column, how are you going to separate those columns? And then you can actually say how it will look like, and that is basically here, column wrap. 3 means you put 3 columns, 3 countries in each row. Okay, all right, so these two are relatively complex functions. I'm going to play with them, but at this point what I want to do is I want to actually go ahead and stop this video. I think it will be too long if I don't. And now in the next video I'm going to talk about these and play with these, and then also talk about other plotting options as well, some other plotting libraries. Now the final thing before I quit, actually, this PLT show is needed if you're running this thing as in Mac. It's not needed if you're using Windows machine. So in the Mac, actually, you have to do this. Otherwise, the Mac backend doesn't actually show you the pictures unless you force them. All right, let's stop here.